My name is Brajesh Gopalan and today we are going to discuss about bar screen chamber. How to calculate the size of the bar screen chamber. So look at this board. The capacity of the plant that it discharge Q is equal to 60,000 cubic meter per day is given. But we have to calculate meter cube per second. So if you divide 24, then you will get meter cube per hour. And again you will divide by 60, then you will get meter cube per minute. And again you will divide by 60, you will get meter cube per second. So this is the basic concept which are explained by me. And here assumed velocity is equal to 0.8 meter second. It has been assumed, not assumed by me, but it is assumed by the CPHO, that is Central Pollution Health Environmental Engineering Organization. So according to that manual, the velocity should be 0.6 meter per second to 1.2 meter per second. But we have taken an average velocity, that is 0.8 meter per second. But the velocity considered below the 0.3 meter per second will be problematic, will be create problem. How? Because if the velocity will be very slow, then the silt will be start to deposit at the bottom of the chamber, and after some times the chamber will be full of the silt, and that is why we cannot take a less than 0.3 meter per second velocity. And again we cannot take a velocity above the 0.8 meter per second. In that case the problem will be arises, like paper, plastic, cardboard, cloths will be passed from the screen. That is why you cannot take. So with a simple formula we know Q is equal to A into V, and we can also write from this formula area is equal to discharge upon velocity, where velocity discharge is 0.694 cubic meter per second and the velocity is 0.8 meter per second already assumed and mentioned in the question problem. So we can find from this formula area is equal to 0.8 meter per meter square. So these three parameters are assumed. Clear spacing between bar is equal to 5 cm, diameter of the bar is equal to 1 cm, and depth of the water is 1 meter. So actually why did I assume? It's depend on the capacity of the plant. So this is the capacity of 60,000 cubic meter per day, but in the case of 1 MLD plant, that is 1000 cubic meter per day plant, its clear spacing is just like only in mm, like 100 mm and 50 mm. So we have to find three things, which is number of the opening, width of the screen, and length of the screen. So as you know, net width of the screen is equal to area divided by depth. Area we have calculated already, and depth which is assumed already. So by this formula we get 0.8 meter per 0.87 meter. But it is the size or width of the chamber. But we have to also install the screen, bar screen in that chamber, and that will occupy the space. So that is why we have to calculate number of opening. So number of opening is equal to net width divided by a spacing between two bars. So net width we have already calculated, and the spacing between two bars. Suppose this is bar and this is also bar. So the distance between two bars is called a spacing between two bars. So the spacing between two bars is 5 cm, but when we calculate in the meter, then we have to divide by 100. So we can get 0.05 meter. So from this formula we have calculated approx 18 numbers of opening. So total number of opening is equal to 18 minus 1, that is 70. Why is it? Look at this chamber. This is opening 1, 2, 3, 4, 5, 6, 7, and the number of bar is equal to 1, 2, 3, 4, 5, 6, and that is why we have minus 1 number of bar. So number of end bar is equal to 2. This is end bar and this is also end bar. So total width is equal to number of opening into clear spacing between two bar plus number of bars into dia of the bars, and from this formula we get 1.09 meter of total width. This is the total width. and we have to calculate from this formula 1 meter is depth and 1.09 meter is width, and from this formula we can calculate length. So length is equal to 2 divided by root 3 into depth is equal to 1.15, and we have calculated width into length, and that is what we have to calculate in the chamber of the bar screw.